Welcome. In this video, we're going to be solving some quadratic inequalities. We're going to work through Algebra 2 Homework 4.6. But I don't know, might be enough room for me. I think I'm going to just use a separate sheet of paper. Okay, the first one is x squared minus 3 is less than 0. And so remember that we're always going to start by setting these things to 0. I guess not equal to 0 because they're inequalities. But we're going to start with that. Okay, well, this one's already done that for us. And then we're going to see maybe can we factor it? It's not a difference of 2 squares, so I'm probably not going to do that. We need to find the zeros. So this one's a little weird because there's a few different ways you could find the zeros. You could use the quadratic formula. You could factor out a difference of 2 squares if you looked at it as x plus square root 3, x minus square root 3, or you can directly solve. I think I'm going to directly solve over here because I haven't done enough of that in my classes so far. So I'm going to say, all right, x squared minus 3 equals 0, because I need to find the zeros to, kind of make my sketch. That's where x squared equals 3, so we can take the square root of both sides. We just have to remember that that's the absolute value of x equaling square root 3, and that's going to give us a plus minus. But you don't need to show that stuff, right? If you just go from x squared equals 3 to x equals plus or minus the square root of 3, that's just as good. I just remind you why that's the case. So, okay, I'm going to draw myself a parabola that opens up because it's positive x squared. And this is negative square root 3 at this one, and over here this is positive square root 3. And we're interested in where this is less than 0. So I'm going to say, okay, that's over here. That's where the parabola is underneath the x-axis. So it's going to be between negative root 3 and root 3. Since it's strictly less than 0, it's not going to include the places where it's equal to 0. So it'll be negative root 3 less than x less than positive root 3. Okay, number 2. X squared plus 2x plus 4, okay, yep, greater than or equal to 0. Hey, I'm thinking to myself, is this factorable? What are two numbers that multiply to positive 4 while adding to positive 2? Not going to happen, okay? All right, so we got to use the quadratic formula. Okay, now I like to check b squared minus 4ac first before applying the quadratic formula, just to see if it's like, oh, if b squared minus 4ac is negative, I'm not going to have any solutions anyway, and then I'll know what to do. So b squared minus 4ac, in this case, blue pen, yeah, that's going to equal 2 squared minus 4 times 1 times 4. That's negative. Okay, so this has no x-intercepts. It has no zeros. So I know that if it opens up and it's got no intercepts, well, it's going to look like this. And that will mean I have, it's always true, right? This parabola is always above the x-axis or on the x-axis. So I'm going to say that this is true for all real numbers. Number 3. X squared minus 6x plus 9 is greater than 0. I wish I would have reordered these problems. I feel like there's kind of a lot of tricky ones at the beginning. I would like to have gotten you started with some easier ones, but these are the choices we make. So x minus 3 times x minus 3. This is factorable. Okay, so I'm seeing the same factor twice. So I know that I only have that one x-intercept here where x is equal to 3, and that that's also where the vertex is. Okay. And greater than 0, okay, that's almost always. Okay, it can't be equal to 0, though, and it's equal to 0 over here at x equals 3. So I'm going to say this is true for all x except for x equals 3. So I'll just say x is not equal to 3. Okay. Number 4. 2x squared minus 5 is greater than x. Or equal to. Okay, and so we got to start by setting to 0. So 2x squared minus x minus 5 greater than or maybe equal to 0. And then, I'm thinking, see if I can factor it. 2 times negative 5 is negative 10. Two numbers that multiply to negative 10 and add to negative 1, I can't think of any. So I'm going to use the quadratic formula. b squared minus 4ac, okay, it's going to be positive because I've got the opposite signs here of a and c. So I'm going to say, all right, I need to get my zeros. X equals negative b, that's positive 1, plus or minus the square root of b squared is going to be positive 1, minus 4 times 2 times negative 5. 8 times 5 is 40. All over 2a. So this is x equals 1 plus the square root of 41, all divided by 4. Or x is equal to 1 minus the square root of 41, all divided by 4. Okay, let me make sure I did that right. T squared minus 4ac. Yep, that's 41. Yeah, okay. Feel good about that. Okay, now that I've got my two zeros, I'm going to sketch the graph of this thing. And we're interested in where this is greater than or equal to 0. All right, so that's going to be here where it's equal to 0, and then also out here where the parabola is above the x-axis. Okay, now I'm going over here, and this is 1 on the left. I have 1 minus root 41 over 4. I'm not even going to write those down. Okay. Because I know that I'm talking about where it's less than the one that's, where x is less than the left 0, which will be this one, the lesser. So x is less than or equal to 1 minus 41's root over 4, or maybe x is greater than or equal to 1 plus square root of 41 divided by 4 for, you know, that piece out there. All right. Number 5. Oh man, this is kind of dirty. They want you to, like, try to take the square root of both sides. And square root, it might preserve the inequality, but I'm not certain, okay? And so I'm just going to be safe here. And there might be a slicker way to do this, like with graphing. Let me think about this. Nah, we're going to set them to 0. That's what we do in this class. You know, like we start solving these inequalities by setting them to 0. So what I'm going to do is I'm going to expand x plus 2 squared. And that's good for us to practice. X plus 2 multiplied by x and plus 2. Okay, that's going to be x squared, 2x, 2 more x, and 4. Okay, so I've got x squared plus 4x plus 4 is less than 25. I'm going to subtract 25 from both sides. Okay, two numbers that multiply to negative 21 and add to positive 4 are going to be positive 7 and negative 3. So I've got x plus 7 multiplied by x minus 3 is negative. That's something I know how to sketch. So if you just had faith and went through the algebra, it ended up being factorable again. I'm going to draw in an x-axis here, okay, because I know that these zeros are at x equals negative 7 and positive 3. And if I'm interested in where this is less than 0, oh, I kind of drew it. I usually like to draw those open circles over there, but maybe I'll just give it a little bit of separation there. Okay, so it's got to be between negative 7 and 3, but not including negative 7 or 3 because it's where it's strictly less than 0, below the x-axis. So negative 7 up to 3. Yeah. Number 6. Okay, 4x squared plus 12x is less than or equal to 9. Well, that's too bad. Okay, there's going to be a common factor. 4x squared plus 12x less than or equal to 9. Okay, start by setting it to 0. So subtracting 9 from both sides. Let's try to factor, right? Two numbers that multiply to negative 36 while adding to positive 12 to negative 6. And I feel like this is going to be a perfect square trinomial because of well, the repeated number here and the fact that we've got two square numbers over here. But I'm just going to factor using the technique that I'm familiar with, that I know works, and then I'll see if it's perfect square or not, just based on the algebra. So I'm going to split up 12x into, wait a second, negative 36 adding to positive 12. Did I copy that right? Hold on, let me look this real quick. You know, maybe I copied it wrong, or like on the actual problem. I didn't copy it wrong when I'm doing it right here. This is what it's supposed to be. So we're going to have to use quadratic formula. It's not going to be factorable, okay, because of that negative there. If it had been less than negative 9, then we would have really been in business. But, you know, I'm going to say x equals, okay, I'm going to do the quadratic formula, and then I'm going to put my sketch over here. So I got to find the zeros next. So I know that x equals negative b plus or minus the square root of b squared minus 4 times 4 times 9, so plus 16 times 9, which might be, that's another 144, because 90 and 54. So it's going to be the square root of 288, all divided by 2a is 8. Okay, so we've got ourselves a positive leading coefficient parabola. Okay, we've got the two zeros. Okay, we've got over here negative 12 plus the square root of 288. Divided by 8. No, that's going to be minus, pardon me. Plus or minus, the minus is going to go on the left. Okay. Just get an eraser. Meaning that this one on the right is going to be negative 12 plus the square root of 288. Divided by 8. Okay. And if we're interested in where this is less than or equal to 0, it's going to be here where it's equal to 0, and also down here where we are below the x-axis. So I'm going to say that the solution, maybe I'll write this one in interval notation, negative 12 minus the square root of 288, all divided by 8, up to negative 12 plus the square root of 288, all divided by 8. And that was not the best numbers ever, also not the worst. Three more of these. Okay, good. We've got one that's got a negative leading coefficient. I was really worried that we were going to go through all these and there wasn't going to be any. All right, so number 7, x squared plus 3x less than negative 8. All right, so we're going to add 8 to both sides. Okay, not factorable. I can't think of anything that multiplies to 8 and adds to 3. 4 and 2, 8 and 1. No, not going to work. So I'm going to use the quadratic formula. And I have a suspicion that this one's going to come back no solution. Right? I'm saying that b squared minus 4ac equals 9 minus 32, which is negative. Okay, so there's no zeros. So I even should have written that out the other time. And if we've got no zeros, and we've got a parabola that opens up because of the positive leading coefficient, it'll look like that. Okay, the vertex will sit above the x-axis. And I feel like I had something else to say about that. Oh, when is it less than 0? Never. Okay, so I could say never, I could say no solution, I could say that, whatever you want. Express yourself. All right, number 8. Negative x squared plus 2x minus 8, okay, good, is greater than 0. It's already set to 0, so that's good. I want, okay, this is negative, but I'm pretty bad at I'm really good at factoring when the leading coefficient is 1. Not so great at factoring when it's negative 1 or, when it's something else. It makes it harder. So what I'm going to do is I'm going to factor out the negative before I start factoring. So I'll have x squared minus 2x plus 8, again with the typing error. I really think that's what it is. I really think I must have typed these in wrong, because this is very similar to a college algebra homework I gave like 5 years ago, and who knows, maybe that's what I was getting at. Okay. As it's written, this one's going to come back no solution also, but I don't want that to happen. So I'm going to change this originally to plus, and that would make this a minus. That's going to be more like it. That will give me 2 distinct zeros and give me the actual problem to work, and it'll be good. So I know that, once again, just to reiterate, I know that this is not what is written on your homework paper, but if you just work it the way it's written, you're going to get no solution again, and that's just not, you just had one that was no solution, so we don't need that. All right, I'm going to factor the thing in parentheses, and I think of 2 numbers that multiply to negative 8 while adding to negative 2. That would be negative 4 and positive 2. Okay, and that's going to be greater than 0. Okay, I can draw a picture of this graph, okay, because I know that it's opening down because of the negative x squared. It's got 2 zeros, one at negative 4 and one at negative 2. Nope, no. That's not true, right? X minus 4 equals 0 when x is positive 4. Okay, so I need to switch those. Okay. Because I made the error, I probably need to be a little more explicit about what I'm doing here. So the zeros would be where x minus 4 equals 0. That's x equaling 4. Or maybe when x plus 2 is equal to 0, and that would be when x is negative 2. So that means this is negative 2, and that's positive 4. Okay, that's more like it. Now, if I'm interested in where this is greater than 0, that's going to be up here between negative 2 and 4. And I'm going to say, all right, maybe I'll use interval notation again this time, and I'll say it's negative 2 to 4, like that. Okay, the last one of these like kind of flat inequalities, it's only 3 pages, is x squared is greater than or equal to 7. I wish it was x squared greater than or equal to like 16 or something, but it's okay. I guess we did one very similar to the first one, but it's okay. We need our practice. So I'm going to subtract over here to x squared minus 7 is greater than or equal to 0. The other time I did direct solve over here in red on number 1, maybe I'll factor this one. Show you that you can factor this as a difference of 2 squares. Okay, x squared is the square of x, right? That's pretty clear. But what is 7 the square of? Well, square root 7. So we can do x plus square root 7 and x minus square root 7. Okay. And then we'll know that the zeros of our parabola are going to be square root of 7 and negative square root of 7. Okay, it's going to open up because we've got positive x squared here. That's a pretty rough parabola, but it's okay. We've got right here negative root 7, and over here positive root 7. And I'm not thinking. Greater than or equal to 0. Okay, here are the places where it's equal to 0. Here are the places where it's greater. All right, so I'm going to say x greater than or equal to square root of 7, or maybe x less than or equal to negative square root of 7. And this is why you can't just like take the square root of both sides of an inequality and just have the solution, right? Is that we have to think about what happens when we square a negative number, basically. So, wait, no, there's 10, 11. Okay, yeah, here they are. Give the intervals on which the function is positive and negative. So, essentially what we've been doing, right? After we set these things to 0. So, for 10, f of x is 2x squared minus 4x minus 3. Okay. We're interested in finding two numbers, if I'm going to factor it, finding two numbers that multiply to negative 6 while adding to negative 4. 2 and 3, 6 and 1, not going to work. Got to use quadratic formula. Okay, that's okay. We can use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times 2 times negative 3. 8 times 3 is 24, so that's plus 24. All over 2a is 4. Okay. I might show, no, 16 doesn't, or yeah. This is 16 and 24. That adds to 40. And if I was to simplify that radical, it still wouldn't divide away. 4 wouldn't divide it. So I'm not going to simplify, except for maybe to say, all right, x equals 1 plus root 40 over 4. And x equals 1 minus root 40 over 4. Right, because we could do that. Multiply each of these things by 1/4 when we're dividing their total by 4. Right. But we know this is parabola that opens up, and it's pretty narrow, so we shouldn't have too much trouble finding, the intervals on which it's positive and negative, because we've already got its zeros. And I'm actually just going to call that x1 and x2. That's x1, and that's x2. All right. And now if I want to know where it's positive and negative, okay, I'll say f is greater than 0. That's when x is greater than x2 or less than x1. X is greater than 1 plus root 40 over 4. Or maybe x is less than 1 minus root 40 over 4, because that's positive right here. I'll get some highlighter or something. 1 minus root 40 over 4. Yeah, still visible. Let's see, do I even have a highlighter in here? I remember the last time I used one. Find one. All right. So f is greater than 0 up here, right? Let's see. How's it going to be? Yeah, that's fine. Okay, right there. Okay, those are the places where f is greater than 0. And then f is less than 0 in the middle here. So I might color it in. And maybe I got. Let's see. I don't remember if this pink highlighter has any juice in it. It's probably a few years old. Oh, looks good to me. Okay, so that's down here. Okay, let's see, that's between x1 and x2. So 1 minus root 40 over 4 is less than x, is less than 1 plus root 40 over 4. And that's how we're going to do that one. We got 2 more of these, so let's hope that one of them at least is factorable. Maybe both of them will be factorable. Okay, so 11 is going to be x squared minus 4x minus 104. Oh, no? Yeah. It's almost too obvious. Okay, equals x squared minus 4x minus 140. Okay, this is factorable. Okay, think to yourself, what's the most obvious factors of 140? I mean, I was thinking about 70 and 2 and 20 and 7, but it's 10 and 14, right? And those, we can make that into maybe negative 14, positive 10 would add to negative 4 while multiplying to negative 140. So we're going to say equals x minus 14 times x plus 10. And, okay, we know what this looks like. Okay, we're going to have our zeros here where x is negative 10 and where x is positive 14. Okay. And so if we're interested in where f is positive, that would be x bigger than 14 or x less than negative 10. And then f is going to be negative when x is between negative 10 and 14. Okay, so we're talking about here and there. Okay, so that's between negative, less than negative 10, caught that. Okay, so x is between, so I might write it negative 10 less than x less than positive 14. All right, number 12. H of x, okay, good, another one with a negative leading coefficient. Wish it was factorable, but it's not, but it'll be all right. So h of x is negative x squared plus 6x minus 10. And what am I thinking? Oh yeah, okay, I'm gonna, if I was gonna try to factor it, I would take the negative out first. And, unless there's something I'm missing, there's no numbers that multiply to 10 and add to negative 6. I'm just not thinking of them. So we're going to use the quadratic formula. Hey, I'm going to use on these coefficients because on the quadratic formula, it doesn't matter if a is negative or whatever. It's going to be fine. B squared minus, yeah, so x, no, wait a second. I need to check b squared minus 4ac. I realized that when I was first doing the problem. It kind of escaped me. Okay, so checking the discriminant. B squared minus 4ac is going to equal positive 36 minus 4 times a times c. Okay, so this is positive 40 here. 36 minus 40 is negative, so there's no zeros. Okay, and since it opens down and it has no real zeros, I know that it's going to look like that. Okay. And so I can say that f is greater than 0 never, no solution, something like that, or f is negative always, all real numbers, something like that. To keep with the same color scheme I've been using, f is negative along this whole parabola, right? Always negative. What that's saying is no matter what x you put in to h is going to come back as a negative number. Okay. That's number 13. On a foggy day, the clouds are only 15 meters high on a golf course. If a player hits a golf ball with height modeled by, okay, here it is, h of t equals negative 5t squared plus 28t, how long is the ball in the clouds? Okay, so we're just going to say, oh, in the clouds, okay, I should probably draw us a, okay, this is going to be my time axis, and maybe like that, and then height. Okay, the level of the cloud is going to be, I'll even draw a cloud, you know. It's going to be 45. And then there's going to be, the ball's going to go up, and then it's going to come down. And so our idea is to find, how long is, what values of t makes h of t greater than 45? This is what I'm saying. Ball is in the clouds when h is greater than 45. Okay, we're not interested how long the ball's in the air. That would be, the distance between the two intercepts on the t-axis. Okay, and I forgot what I was going to do here. Oh, yeah, I actually saw this inequality. So negative 5t squared plus 28t is greater than 45. I feel like I'm supposed to be able to factor this one, but man, I am not seeing it. Plus 28t minus 45 is greater than 0. Okay, I can't factor out the 5. I'm not thinking it's terribly likely that I'm going to be able to find factors of 45 times 5. Well, 40 times 5 is 200. This is 225. Ooh, there are a lot of things that multiply to 225. Hold on a second. Let me investigate. Okay, I see now. That polynomial had no zeros because I copied it wrong. This is not 45. This is 15. I'm not really sure where I got 45 from, but okay, so h needs to be greater than 15. That means this is a 15, and then this is going to be a 15 also. Okay, now we're looking for 15, 30, 45, 60, 75. Yeah, two numbers that multiply to 75 and add to 28. Yeah, that's 25 and 3. Okay, I'm back in business now. So I'm going to factor over here by splitting the positive 28t into 25t and 3t. So I'm over here. I'm saying negative 5t squared plus 25t plus 3t minus 15. That's got to be greater than 0. Okay, now I'm going to group and factor. And I'm going to have, what's common to both of these, I'm going to take the negative out, I'm going to take a 5 and a t. So what would I multiply negative 5t by to get negative 5t squared? Just 1t. And then I would have to multiply this by negative 5, I think. And then 3t and negative 15, what's common to those is the 3. So I'll factor out plus 3 times t minus 5 is greater than 0. Okay, but since I know that really I'm just interested in the times here, I'm not going to sketch another parabola. I'm just trying to find the factors here. I'm factoring out a t minus 5. I'm left with a negative 5t plus 3. And, okay, the first 0, t equals 5. Okay. Well, I guess that's probably going to be the second one, right? That's going to be when the ball comes down out of the clouds, I would assume. Okay, this one maybe not as obvious, so I'll solve it. See where it's equal to 0. Subtract 3. Divide by negative 5, and t is 3/5. Okay, so this right here is t equals 3/5, and this right here is t equals 5. 3/5, it's also 0.6. So I'm going to say this is up in the air for 4.4 seconds, which is what I got when I did this problem for college algebra. Okay. So that was... okay, that time interval is how long the ball is in the clouds. Right. Oh, no more room. A soccer ball is kicked on a flat planet with low gravity. Its height is modeled by h of t equals this. How long is the ball in the air? Okay, give a sketch to support my answer. Okay, that's just where we're going to sketch. Negative 2t squared plus 18t. I guess you don't necessarily know that. I'm going to factor this thing first. I'm going to factor out the negative 2 and the t, because both of these have a t in them. So I think, what do I multiply negative 2t by to get negative 2t squared? That would be a t. And what do I multiply negative 2t by to get positive 18t? That would be minus 9. Okay. So if we look at it as negative 2 times t minus 9, I know I've got a 0 here where t is equal to 0, a 0 where t is equal to 9. And then, it's a downward-facing parabola, so it looks like that. Okay. I feel like, I don't know, maybe I should probably believe I bet I investigated it whenever I wrote these problems, but that could be high gravity. Negative 2t squared is a very steep parabola, but not going to think about it too much. Okay. Oh, wait, but it asked how long is the ball in the air? 9 seconds. Okay, that'll be good. All right, now we're going to do some review. I'm glad to see that I put this on here. That was, glad I did that. So we're getting close to time to start thinking about the Unit 4 test. And, it's good for us to start practicing the stuff that, there's a few lessons ago we might have forgotten about, like complete the square. I do not want you to forget about that, especially one where the leading coefficient is not 1. So the first step with that, to write it in vertex form, we're going to write vertex form off to the side. Y equals some number times x minus h squared plus k, where h and k are the coordinates of your vertex. Okay, so the first step here is to factor out the leading coefficient of anything that has an x on it. Okay, and then leave room to add. Okay, but then we're also plus 13. Okay, now I didn't leave enough, I guess I'm going to have to add over here. But I'm going to think about, all right, what am I going to add to both sides, or not both sides, because there's that 2. I have to be careful with that. What am I going to add in here to make the thing inside the parentheses a perfect square trinomial? Okay, what we do typically is we're going to take that negative 3. I usually do that with the yellow highlighter. I take negative 3, I divide it in half, and then I square that. Okay, so if I square negative 3 halves times negative 3 halves is going to be positive 9 over 4. So plus 9/4. And I'm going to not just add 9/4 over here, because that wouldn't be fair. What I really added on the right side is 2 times 9/4, which is, you could call it 18/4, or you could call it 9/2. It's the same number, right? So I'm going to add that 9/2 over here as well to be fair to both sides of the equation. And that'll help me complete the square. Now I factor this thing. It's going to end up being, zoom out. It's going to end up being x plus this number on the inside of the parentheses here squared. Say f of x plus 9/2 equals, which is 4.5, so I might use that. 2 times x minus 3/2 squared plus 13. Okay, yeah, and if I subtracted 4.5 away from 13, 13 minus 4 is 9, so 13 minus 4 and a half would be 8.5. So f of x equals 26 minus 7, yeah. Wait, 17 times 8.5, yeah. 2 times x minus 3/2 squared plus 17/2, 8.5, whatever you want to call it. If I'm already doing fractions over here, I might as well stick with fractions over there to be consistent. All right, sketch the graph of f and find the focus in directrix. That's another thing we haven't done in a while. I'm really glad I put these on there. All right, so it's got a positive leading coefficient. We've got the coordinates of the vertex. They are right there looking at us. That's the graph of f. I'm going to label the vertex. Nope, that's positive 3/2, because it's whatever would make this 0, right? So we're having our minimum value, okay? Because if the thing on the inside of the parentheses is not 0, we square it, and we're going to be adding a positive number to 17/2. So positive 3/2 and positive 17/2. And now we need to find the focus, which is going to be about there, and the directrix, which is going to be an equivalent distance down below, and about right there. And we're going to find the distance from the vertex to the focus and directrix, which we have generally called P. Okay, in case you had not done this, our goal is to find P. And the formula is A equals 1 over 4P. Okay. And I've got A, its leading coefficient, it's 2. So 2 equals 1 over 4P. Okay. If you're not sure, multiply both sides by 4P. So 2 times 4P would be 8P equals 1. Okay. And P is 1/8. All right, so that's a distance of 1/8 there, and also a distance of 1/8 up there, but it's a little crowded. I'm not going to get into that. All right. Now, the focus point, okay, it's got the same x-coordinate, it's just up by 1/8. So, oh man, I don't know, 17 times 4, it's 40, and 28, and 68. Okay. So I've got 68 over 8, and then I'm going to add 1/8, so I'll have x equals 3/2, it stayed the same, and y is going to be 69 over 8. And then the directrix is going to be, I'm going to take 17/2 and subtract 1/8. But again, okay, 17/2 to 40 and 28 is 68. Minus 1 is 67. Okay, and this is a horizontal line, so it's going to have an equation, y equals 67 over 8. Okay. And that's how we found the focus and directrix. Okay, looks like the last problem that we've got is one of these, hey, find me the parabola that goes through these 3 points. I gave you one, finally, that did not have the y-intercept given, so we're going to really have to solve a 3x3 system. But, like I'm telling you, that's the best time to really learn something is right when you're about to forget it. So, let's get to it. So we're going to set up our 3 equations from our 3 points, right? We're going to say we're going eventually to a place where y equals ax squared bx plus c. Okay? Where x is -1 and y is -6. Okay, that'll give me -6 equaling a times -1 squared plus b times -1 plus c. And then from the point 1, -2, I'm going to have -2 is y, x is 1, so 1 squared is still 1, x is 1, and plus c. And then when x is 2, y is 3. Okay, so y is 3, a times x squared, 2 squared is 4, plus b times 2 plus c. Okay. I'm thinking I'm going to eliminate on c. Okay, I haven't even cleaned these up quite yet, but that's going to be my plan, I think. So I'm going to say, all right, a minus b plus c. That's the first equation. Equals -6. Then a plus b plus c, oh, maybe I'll just eliminate on b, is equal to -2. And then 4a, 2b, and c is going to be 3. I'm going to think about this for a second. Okay, on one hand, I could add equation 1 and equation 2 together, and then I would be able to eliminate b. And I could add 2 of equation 1 to equation 3. It's about the same. The c's are really, really sitting there nicely for elimination, so that's what I'm going to do. Okay, you could do b though, and you would get the same answer, and it wouldn't be any harder. Okay, so what I'm going to do is I'm going to go over here and I'm going to take equation 1, and I'm going to multiply it by -1. So negative of equation 1 plus equation 2. Okay. And that will be negative a plus b minus c equaling positive 6. And then positive a, positive b, positive c equaling, oh yeah, I didn't even think about that. That would really be helpful. Yeah, okay. I'm glad I eliminated on C and not B. So I'm over here and negative 2. Yeah, add these all together. I'll have 0, 2b, 0. Okay, so I got 2b equaling 6 minus 2 is 4. Wow, it's telling me b equals 2. This is great. And I haven't even tried to eliminate on this equation yet either. So what I'm going to do is I'm going to set up to eliminate over there the negative of equation 1 plus equation 3, kind of like I did before. But now I already know that b is equal to 2, so I'm going to use that, whenever I see it. So the negative of equation 1 is negative a plus b minus c equals 6. Maybe I'll wait until I actually add the equations together to substitute b equals 2. But you could do it now, and it would be fine. Then 4a, 2b, and positive c, that's going to equal 3. And so if I add this all together, I'm going to get 3a plus 3b equals 9. But I happen to already know b. b is going to be 2. So 3a plus 3 times 2 is equal to 9. So that feels like, okay, if something plus 6 equals 9, that thing is going to have to be 3. 3a equals 3 equals 1. Okay, and then now we usually start by getting c because we're frequently given a y-intercept, but it doesn't always have to be like that. In fact, it's only because, somebody was generous and chose to give you the y-intercept, right, that you always got that. In general, you just pick 3 points on a parabola at random, you're probably almost never going to find the y-intercept, but, is what it is. So we're going to go over here. We got a, we got b, we need c. I'm going to take the easiest looking equation, that's that one. A minus b plus c equals negative 6. A is 1, minus b plus c equals negative 6. So I've got one over here. 1 minus 2 is negative 1, plus c equals negative 6. So I think c is going to be 5. No, c is going to be negative 5. Yeah, that makes more sense to me. All right, and so now I can go in and I say my hypothesis, I'm going to make sure that this is true because I've spent a lot of time and effort on it. 1x squared plus 2x minus 5. Let me make sure that, these points fit. When I plug in negative 1, I get 1 minus 2 is negative 1, minus 5 is negative 6. That's a good sign. 1 and negative 2. 1 plus 2 is 3, minus 5 is negative 2. Great. When x is 2, I get 4 plus 4 is 8, minus 5 is 3. Okay, all 3 points fit. Okay, I've got a quadratic equation. Fits all the points. I'm happy. All right, that was kind of a lot, but it was a good selection of practice, and there were some good review problems at the back. And if you did those and you're following with me all the way to the end, that will pay off for you in the future. So that's going to be all. Thanks for watching.